Okay, so today we are still solving trig equations. This time we're going to have to factor. So, kind of like what we were doing at the end on Friday where we just factored out the different terms. This time we're factoring when it's in quadratic form. So this one wants me to find all the solutions of 2 sine x squared minus sine x minus 1 equals 0. So remember, this is kind of like if I had a normal quadratic, like this. Okay, so because I have an a value, I'm going to label my a, b, and c values. And I'm going to use the AC method. So I'm going to take my a and c values and multiply those together. So what's my a times c? What is it? Negative 2. So it multiplies to negative 2 and adds up to my b value of negative 1. So I want to split this up. Instead of having that minus sine x in the middle, I'm going to have minus 2 sine x and then plus 1 sine x. Minus 2 sine x. Minus 1, and it still equals 0. Okay, then I want to go ahead and split these into 2 groups. What does my first group have in common? Okay, so I'm going to pull out a 2 sine x. What do I get left over for my first term? Sine x. And then for my second term? Negative 1. In my second group, what do they have in common? Positive 1. So I'm going to pull out a 1. I'm going to put a plus 1 in between. And then I'm going to write sine x minus 1. And this still equals 0. Okay. Then what do I want to do? So I'm undoing the distributive property here by putting my 2 outside pieces together. Okay, then what do I want to do? Set them equal to 0. So on this first one, I want to subtract 1 on both sides. I have 2 sine x equals negative 1. And then I want to go ahead and divide both sides by 2. So I have sine x equals negative 1/2. Where does that happen at? Pi 6, and where else? Wait, no, this is negative 1/2. So this would be, if I'm talking about negative 1/2, it's going to be in these two quadrants. So remember my rule for this third quadrant is to add the angle, and then my second quadrant is to take 2 pi and subtract the angle. So if I'm in the third quadrant, I'm going to do pi plus pi 6, which gives me what does it get me? I'm undoing reference angles. So that's why I'm doing the opposite operation here. Yeah. So this is going to give me 7 pi 6. And then in the fourth quadrant, 2 pi minus pi 6. Gives me 11 pi 6. And I don't have to do the plus 2 pi n here because I'm restricted on an interval. So I just need to solve my other equation. On that one, I want to add 1 on both sides. Where does sine equal 1? Pi halves. Remember, that is the one where I had the coordinate points. And y is the sine value. So this one is just pi halves. Questions here on number 1. Okay, so number 3, same idea, but, oh, I didn't unfreeze my screen. Same idea, but notice on this one, what's wrong? We had a problem like this when we were factoring. Yeah, I have different trig functions. Before I do anything, I need to make them the same. So I always want to change the one that's squared, because I have an identity for that, the Pythagorean identity. So I'm going to rewrite this as 1 minus cosine squared. You always change whatever's squared, so it could be like a cosine squared that you change. And then I want to distribute this too, so it's going to go to both that 1 and the cosine. So then it's going to turn into negative cosine squared x. So then I want to combine my terms and write this in standard form. So I'm going to have the negative 2 cosine squared out front plus the 3 cosine x. Positive 2 minus 3 gives me negative 1. Huh? This 2 is positive. The 2 in front of the cosine is the negative 1. Okay. Okay, then I want to rewrite this, or not rewrite this, I want to write my A, B, and C values. So my A value is negative 2, my B value is 3, and my C is negative 1. So then I'm going to do my AC method here. So I'm going to take my A value times my C value. Gives me positive 2. So it multiplies to positive 2 and adds to 3. 1 and 2. So then I'm going to split this up. Okay, so then I want to split into my two groups. What does my first group have in common? 2 cosine, and remember, I always want to make my leading term positive, so I'm going to pull out that negative. So what am I left with after I pull out the negative 2 cosine? Cosine of x minus 1. And then in my second group, what can I take out? Just the 1. And then I have cosine minus 1. It still equals 0. Maybe. There you go. Then I'm going to put my two outside pieces together. So I'm going to have negative 2 cosine x plus 1. And then cosine x minus 1 equals 0. Okay, so then I want to take these and set them equal to 0. Okay. this first one, I want to subtract 1 on both sides. And then I'm going to divide by -2. Which is going to give me 1/2. Okay, and then on the second one, I want to add 1 to both sides. Okay, where is cosine 1/2? Okay. And where else? Where else is cosine positive? In the 4th quadrant. So how do I do it in the 4th quadrant? 2 pi minus pi thirds gives me 5 pi thirds. And then where is cosine 1? It's 1 at 0. So this is my final answer. Okay, so sometimes when we're solving, our variable after the trig function has a number either being multiplied or divided by it. So I need to I solve like normal, and this just actually adds 1 more step at the end. So for now, I'm going to treat this as if it's a normal equation. I'm going to add 1 on both sides. I have 2 cosine 3t equals 1. Then I want to go ahead and divide both sides by 2, which gives me cosine 3t equals 1/2. So just like normal, I want to decide where cosine equals 1/2 according to that chart. It is at pi thirds. And because I don't have an interval, it's going to be plus 2 pi n. And then I am going to actually have this equaling 3t right now. So I'm going to have 1 more step to solve. But remember, cosine is positive in 2 quadrants. It is positive here and down here. So I found that pi thirds. I also need to find the angle in the 4th quadrant, which is, remember, 2 pi minus the pi thirds, which will give me 5 pi thirds. So then I want to go ahead and isolate t on both these equations. On the first one, I'm going to divide everything by 3. Pi thirds divided by 3 will give me pi ninths. And then on the second part, I'm just going to leave that as a fraction over 3. So same idea on my second equation. I'm going to divide everything by 3. So this is going to get me t equals 5 pi ninths plus 2 pi n thirds. Then, because I have the variable n, I need to say where n is any integer, because otherwise someone reading this might assume it's a fraction. So this is my whole answer. So same idea on number 7, except this time I'm dividing by a number, so I'm going to solve it like normal. I'm going to subtract 3 on both sides. I have 3 tangent x divided by 2 equals -3. Then I want to divide both sides by 3, which gives me tangent x over 2 equals -1. This one is on my chart. Tangent is +1 at pi fourths. but tangent is negative in these two quadrants. So that is, this rule is going to be pi minus the 5/4. Oops. Oh yeah, x halves equals. The pi minus pi/4 gives me 3 pi/4. Tangent happens every pi, every half a circle. So here is plus, oops, I wanted pi in. And for this one, because tangent happens every half a circle, I only have to find this quadrant because this one will be a full pi later. So then I just want to go ahead and solve. To get rid of my fraction, I'm going to multiply everything by 2. So this is going to get me x equals 3 pi halves plus 2 pi n. And then I'm going to say where n is any integer.